Hello, ladies and gentlemen. This is Mr. Santoro bringing you the next lesson in the limits unit, right from Classroom 174. Hope everybody is doing okay today. So let's take a look at this. When do limits exist? So we talked about limits in class, just what is a limit, how to find it on a basic graph. Now we're getting much more detailed into what a limit of a particular function is. So left-hand and right-hand limits are the idea of looking at what happens to a function as you approach a particular value of x from a particular direction. So this first example, the limit of f of x as x approaches a, whatever x is, from the left. See the negative sign? That means you're approaching from negative territory. Okay? So you're approaching left to right. The next one is approaching a value of a from the right, and that's written with a plus sign after the value of x. So we're approaching from positive territory, we're approaching right to left. So when do limits exist? It exists if the right hand and the left hand limit are equal. So as we trace along the graph, as you approach from the left and approach from the right to the same value of x, if you get the same answer, the same limit in both directions, then that's the limit of the function. But if you approach from the left and get one value and approach from the right and get a different value, the limit does not exist. So let's take a look at the graph that we have here. If you take a look at this, it says the limit of f of x as x approaches 1 from positive territory, from the right, the little plus sign. So if I trace along here, and I'm going right to left, the limit of this function is 2 as I approach x is 1. So that's the first value. So now the next one is, what is the limit of the function as you approach x equals 1 from the left? Well, I can't approach x equals 1 from the left up here because there's no graph there. So I've got to now trace along the other line that's graphed, and I need to go left to right approaching x is 1. And if you remember, the function does not have to attain that value of y. The limit is looking at what value the function is trying to attain. So as we trace along here left to right, as we approach 1, the limit of this function will be 1. 1 is the value that the function is trying to attain. It doesn't get there, but that's where we're approaching 1 as you approach x equals 1. So if I approach from the right, I get a limit of 2. When I approach from the left, I get a limit of 1. Therefore, the limit as x approaches 1 does not exist. So f of 1, all that is okay, when x is 1, what's y? Well, you have an open circle and a closed circle. The closed circle wins. So when x is 1, y is 2. The next one I'm asking, as x approaches 4, what's y? So if I approach 4 from the left, y is 2. When I approach x equals 4 from the right, y is 2, so the limit of this function is 2. The last part is, what's the limit of the function as x approaches 0? So I can approach 0 from the left, I get 0. I can approach 0 from the right, and y is still 0, so the limit of that function is 0. As x approaches 0, the limit is 0. If you need to go back over this, rewind it and watch this again. But I'm going to move on now. So if you need to watch it one more time, you rewind it. So now this is a little bit of a crazy graph here, but there's a lot of things going on. So you've got one function here that does this crazy stuff. Then you've got this absolute value function here. And then you have a closed circle at 1, -1 right down here. So let's take a look at this. The first thing I'm asking you for is, as x approaches -2 from the left, the minus sign, so I'm going to approach -2 from the left, my limit is 2. Now I say, okay, approach -2 from the right. Well, to get to -2, I've got to trace along this function, and as x approaches -2, y again is 2, So the limit of this function as x approaches -2, the limit is 2. So now, let's take a look at the next thing I'm asking you to do. When x approaches 0 from the left, so the only way I can get to 0 from the left is trace along this line. So as x approaches 0, the limit of this function is -1. Now, to approach 0 from the right-hand side, the only way I can get to 0 going right to left is along this graph. So as I approach 0, y is 3. So if those two values are different, the limit of this function, the limit just does not exist. So if you look at the top two, when I approach x is -2 from the left and the right, I still get a value of 2. Therefore, the limit is 2 when I approach -2. On the second example, as I approach 0 from the left, the limit is -1. As I approach 0 from the right, the limit is 3. And since they don't match, the limit, this function, the limit simply does not exist. So if you need to go back and replay it, do that. Otherwise, we'll be doing practice problems in class. So I'll see everybody on Tuesday.